Hey there, in our last lesson, we talked about how you can prove two triangles are congruent by showing that all the corresponding parts are congruent. And that was a lot of work because we had to show that there were 3 pairs of congruent sides. We had to show that there were 3 pairs of congruent angles. And so altogether, that was like 6 pairs of things that we had to first show were congruent in order to claim that the triangles were congruent. Okay. Now this lesson is going to completely simplify that process because there are actually some particular patterns that we can use where we can show fewer things. Okay? So one of them in particular is called the, I just call it the side angle side pattern, but it's really called the side angle side theorem, right? Which basically says if you have 2 triangles and you can show that they have 2 pairs of congruent sides plus the angle in between those sides is congruent as well, right? Then you can, that is enough information to say that the triangles are congruent. So in other words, we're cutting out a lot of our work and really only having to show that there are 2 pairs of congruent sides and 1 pair of congruent angle to show that the triangles are congruent. Okay. The thing to remember, though, it's not any 2 sides and it's not any angle. It has to follow this side angle side pattern. All right, so we need a side, an angle, and a side. A side, an angle, and a side. Okay, so if we can find that pattern of congruency within the triangles, then we can say the triangles are congruent. Okay. All right, so here's question number 1. And so we have these 2 triangles here which happen to share one of their sides. Here's what we know. BD is perpendicular to AC. We see the little right angle there. And AD is congruent to CD. We see the tick marks there. Okay. We want to prove that the 2 triangles are congruent. All right. So let's start by, let me just color in the triangles. Okay. So we've got this, we'll call it the yellow triangle here. And let's color this one orange. Okay, so we have an orange and a yellow triangle. The yellow triangle is named ABD, the orange triangle is named CBD. And what we're trying to find is this side angle side pattern of congruence. Right. So with any proof, we can always start with the given and end with the prove. So I'm going to write, BD is perpendicular to AC, given AD is congruent to CD, given, and then the final thing is that the triangle ABD is congruent to the triangle CBD. And I'm already going to give away the reason here, right? The way we're going to prove this is not by showing that there are 6 pairs of congruent things, right? 3 sides and 3 angles, but it's just showing that we can find this side angle side pattern, right? So side angle side theorem. Right? So look, I already have my first statement is about a side. So then I need to find an angle, and then I need to find another side. Okay. So I'm actually going to, next to my first column, I'm going to write side angle side. So remind myself that's the pattern that I need to find, and that's going to be the statements that I need to write. Right. So AD and CD, right? You can see those are the ones with the tick marks. So we have 1 pair of congruent sides so far. Okay. Let's find a pair of congruent angles. Okay. Well, notice in the diagram we already have a marking here of a 90-degree angle. Okay, so my question would be, what angle would be over here? Right, like if I call this angle number 1 and I call this angle number 2, right? How many degrees would angle 2 have? Well, it would also have to be 90 degrees because the lines are perpendicular, and the definition of perpendicular is that the angle at the point of intersection is going to be 90 degrees. Okay. So we can go ahead and write angle 1 is congruent to angle 2, and we'll use definition of perpendicular. Okay. So we've got our side, we've got our angle, now we need to find the next side. So we've got side, angle, and so here's going to be the third side. So we want side, angle, side, side, angle, side. All right. So this next side is actually the side that the two triangles share, right? The yellow triangle has BD as one of its side, and the orange triangle has VD as one of its side. So the fact is they share this side. In other words, the side it's the same segment for both triangles, right? So we can write BD is congruent to itself. Okay. So in math, right, and just logically speaking, anything is congruent to itself, right? The number 5 is equal to itself. Any angle would be congruent to itself. Any segment would be congruent to itself. Okay. So whenever we're saying that something is equal to itself or something is congruent to itself, what we're using is the reflexive property. Right. And we can use that right here because all we're saying is that a segment is congruent to itself. And that's pretty much our proof. It's about 5 lines. Okay. So the first statement is about the perpendicular lines. The next statement is about a pair of congruent sides, then a pair of congruent angles, and then another pair of congruent sides, giving us that side, angle, side pattern. Okay. And that pattern, luckily, is enough to say that the triangles are congruent. Okay. I don't have to go and show that these two angles are congruent. I don't have to go and show that these pair of angles are congruent. I don't have to show that these sides are congruent. I just have to find that side, angle, side pattern. All right, I'm going to stop this video here. As you can see, there is a second proof, and that's going to be in a follow-up video.